the introduction. Okay, firstly, I will explain about the Green's theorem. Okay, Green's theorem is one of the connection for differentiate and integrate in multivariable calculus. It is the name of the self-taught by George Green, English scientist, in the year of 1793 until 1841, who is full-time with his father. Okay, now we go to the Green's theorem applicable. This theorem is applicable for simple closed curve and only suitable to use in two-dimensional. Now we go to the front left-hand side by using Green's theorem. Okay, first we will look at the general equation of the Green's theorem, which is integral of the p dx plus q dy is equal to double integral qx minus py dE. And we take one example of the integral equation, which is equal to integrate 2y squared dx plus 4x dy. And this equation will be complete with diagram 1 and represent as the left hand side. So that for the integral, the value of p is equal to 2y squared and the equation of the q is equal to 4x. And the right hand side is the value of q will differentiate with respect to x minus the value of p will differentiate with respect to y, and it will be equal to 4 minus 4y. Then the equation will be easy to solve. Okay, now we go to the Stokes theorem. Okay, the term of the Stokes theorem has been given by the Sir George Stokes in the year of 1819 until 1903. With the Irish mathematical physics, he was most widely known for his investigation of the fluid flow and light. Stokes theorem is a version of the Green's theorem, but in a high dimensional. According to this theorem, the surface integral over a surface is equivalent to a line integral over the boundary curve of a surface, which is the space of the curve. Okay, now we go to the applicable of the Stokes theorem. Okay, this theorem can always be applied and to consider several conditions. Firstly, vector field must be axis on the surface integral, and it must have an ability to be written as the gradient of the vector pushed by the vector f, which is the vector f must be able to find. And this is also effective only if the surface is completely connected without any holes. And finally, if the boundary of the body approach infinity in either direction or becomes indeterminate someplace on the surface, then Stokes cannot be applied. Okay, next we go to the using right hand rules by Stokes theorem. Okay. Firstly, choosing the correct orientation is as simple as utilizing the right hand and curling the fingers in a counterclockwise direction from the side of the thumb. The thumb is represented by the normal vector n of a surface. If the thumb is pointing the positive side of the surface, the fingers show the circulation corresponding to the curl of the vector f dot by the vector of n on the surface. If the relationship between the normal vector n and the orientation of the C does not match the relationship between the thumb and the fingers of the right hand, the result will be of a minus sign.
Now I'm going to present the similarities and relationship between Green's theorem and Stokes theorem. Green's theorem gives the relationship between a line integral around a simple closed curve C in a plane and a double integral over the plane region R bounded by C. It is a special two-dimensional case of Stokes theorem, where Green's theorem equal to Stokes theorem for the positive surface orientation. Stokes theorem gives the relationship between a line integral around a simple closed curve C in space and a surface integral over a piecewise smooth surface S. Stokes theorem can be regarded as a higher dimensional version of Green's theorem because it describes the positive and negative surface orientation. It also generalized Green's theorem to three-dimensional. Nevertheless, when they serve the same purpose, the differences are not so significant. The similarity between these two theorems are where both of them used to identify the line integral around a closed curve in the absence of direct calculation. The fact that the problem can be simplified into a simple one is what makes these formulas user-oriented.
There are 5 mathematicians and physicists who contribute to the discovery of Green's theorem and Stokes theorems. Firstly is George Green. He is the son of Nottingham Becker, who was born on 40th July 1793. He is an English mathematician and physicist. He shows his interest in mathematics at the age of 8. Green's life is worth of attention because he was almost entirely self-taught since he only had 1 year of formal schooling, then he went to work at his father's mill. His contributions in Green's theorem started when he wrote an essay on the application of mathematical analysis to the theories of electricity and magnetism. Next is Augustin Louis Cauchy. He was born on 21st August 1789 in Paris. He is a French mathematician, engineer, and physicist who contribute to several branches of mathematics such as divergence and convergence of infinite series, probability, differential equations, mathematical physics, and determinant. His contributions in Green's theorem is when he proceeds to use the Green's theorem in process of proving Cauchy theorems on the integral of complex functions around a closed curve. The third person is William Thomson, as known as Lord Kelvin. He was born on 26 June 1824. He was an Irish-Scottish mathematician, mathematical physicist, and engineer born in Belfast, Ireland. He is a genius child. He learned mathematics with his father at a very young age and had knowledge on the latest update in certain subjects. His contribution in Green's theorem is in 1945. He rediscovered Green's essay and popularized it for the future mathematicians when he worked at Paris Laboratory. The fourth person is George Gabriel Stokes. He was born on 30th August 1819 in Skene, Ireland. He was an Irish physicist and mathematician. He mostly spent his career at the University of Cambridge as a student and also as a professor. His contribution in Stokes theorem is when he made Green's work as reference in his research paper. The theorem named after him because of his habit putting the theorem as a mathematical problem on the Cambridge examinations, therefore resulting to Stokes theorems. Lastly is Hermann Hankel. He is one of the students of George Gabriel Stokes. He was born on 40th February 1839 in Halle, Germany. He was a German mathematician who worked on the theory of functions, theory of complex number, and the history of mathematics. Hankel is the first who published the proof of the Stokes theorem in Smith Prize exam at Cambridge in 1861. Unfortunately, he did not manage in any major contribution in mathematics until he died at the age of 34.
Now we go for the roles of Green, Thomson, and Stokes in discovering theorems and making them widely known. Green's theorem is named after the self-taught British scientist George Green. In 1828, he published a pamphlet privately, but only 100 copies were printed and most of those went to his friend. This pamphlet contained Green's theorem, a two-dimensional result that Green also did not consider. It actually did not widely known at that time. Then, Green entered Cambridge University for undergraduate studies at the age of 40, but died 4 years after his graduation. Here is when William Thomson took part. In 1846, Thomson discovered a copy of Green's paper, realized it is important and reprinted it. And the most important is Green's work served as the basis of later electromagnetic theory of Thomson, Stokes, Rayleigh, and Maxwell. Next, we go to Stokes theorem. Sir George Stokes was the inspiration for Stokes theorem. He had for several years been setting the Smith Prize exam. Therefore, he urged students to prove the theorem in an examination in 1854. It does not appear that any of the students were able to prove the theorem. However, the theorem had already been published in a letter from William Thomson to Stokes on 2nd July 1850. The left-hand expression of the theorem had already been published in the two Stokes' earlier writings. In 1861, Hermann Hankel appears to be the first published proof of the theorem, but he gives no credit for the theorem. This makes Clerk Maxwell wrote to Stokes in 1871, inquiring about the theorem's history. Then, Stokes evidently responded because the theorem appears with a reference to the Smith Prize exam in Treatise on Electricity and Magnetism, written by Maxwell.
We'll present 4.1, which is History and Application of Green's Theorem and Stokes' Theorem in Electricity and Magnetic. The history of Green's Theorem and Stokes' Theorem. George Green is an English scientist who was born in 1793. He only went to school at the age of 8 years old and stopped at the age of 9 years old because he needs to help his family business. Next, because of his love for mathematics, he then joined library in Nottingham in 1823. His essay, An Essay on the Application of Mathematical Analysis to the Theories of Electricity and Magnetism that documented Green's theorem, was privately published in 1828. Only 100 copies were printed, and most of the copies were given to his family and his friends. Green stayed along his essay on electricity and magnetism and completed his degree in Cambridge at the age of 40. 4 years after that, he died, and his essay was then discovered by William Thomson in 1846 and reprinted it for the future mathematics. The essay was then obtained by George Gabriel Stokes, and then he put the theorem in Cambridge Prize examination in 1850. Stokes' theorem is a complex version of the Green's theorem. Next, I will talk about application of Green's theorem and Stokes' theorem. The first example is Maxwell-Faraday law, where it describes how a time-varying magnetic field creates an electric field. The next example is Ampere's law. It is very useful to calculate the magnetic field in highly symmetric cases when the magnitude is taken out of the integral form to find that the magnitude is constant along the boundary. Stokes' theorem states that the line integral around the boundary curve of the tangential component is equal to the surface integral of the normal component of the curl of f.
Okay, next in my part, I will present to you about the example of the theorem in application and how the theorem are used to study those physical problems. Okay, first I will be explain about the Green theorems. In classical mechanics, Green's theorem was used to determine the momenta of two-dimensional shapes and axially symmetric bodies. And the following equation that was used was, which is the integral of L dx plus m dy, which is equal to double integral of differentiate x in m minus differentiate of y in L dx dy. Next, Green theorems was used in electrodynamics to establish the link between the integral and differential Maxwell equation, and as a result, Green's theorem will be utilized to demonstrate the relationship by deriving the differential Faraday's law from the integral form. Okay, for the last part in Green theorems, in physics, Green theorems was used to determine the energy of current, and as a result, we consider a current loop as a superposition of small loop, and the energy contained within a tiny loop can be seen at the right figure. Next, for Stokes' theorem part, in physics, Stokes' theorem is also applicable, particularly electromagnetic physics. So when determining the curl of a vector field, this theorem is employed. So Stokes' theorems and its modified form are indispensable for calculating the line integral of a given curve and the curl of a bounded surface. And the following example illustrate the theorem, which is given double integral of scalar product of curl f and ds, where the function of the vector field of f is equal to xzi plus yzj plus xyk. Okay, next, continue for the Stokes theorem part. Stokes theorem has 3 experiments, which is the first and second experiment is generate motional EMF, which is the formula is epsilon equal to the differentiate of T in negative phi as defined by the flux rules. And the third experiment is the third experiment, the Stokes theorem was established that a changing magnetic field generates an electric field, and the equation for the electric field is as follows.